Okay, I'm going to go over question 5 from Thursday's class. It says the circle K has a center of 1, -2 and a chord with endpoints at A and B, where the distance from A to B is 4√3. To point D, 3, 2 is the midpoint, so that segment is equal in length to that segment. Here's the midpoint of the chord as shown below. Find the radius of K. Okay, so it's the midpoint. Given that the whole length of that is 4√3, that means each of these little segments, the distance from A to D must be 2√3. That distance must be 2√3 also. I'm trying to find the radius. I'm going to be using one of the theorems on your course, which is Theorem 21, which says if I draw a radius to a midpoint through a midpoint of a chord, well, that radius and that chord will meet at right angles. Okay, so I have a little right triangle in here. I'm thinking about Pythagoras. To find the radius, all I really need to do is find that length there. And I can use the distance formula. And the distance formula will say that that distance from C to D is going to be equal to the square root of the horizontal change squared, which is horizontal change there is 2, so 2 squared, plus the square of the vertical change. Vertical change here is 4, that's 4 squared, which is going to be root of 4 plus 16, which I think is root 20. That reduces to 2 root of 5. So I have 2 root 5 here. To find the radius, let's call it or. I'm just going to use Pythagoras' theorem again. Or is equal to the square root of the square of 2 root 3 plus the square of 2 root 5. Simple as that. We have a little right triangle in here. We're just using Pythagoras' theorem. And that's the square root of squaring 2 root 3. Well, that's 4 3's, which is 12. Squaring 2 root 5. That's 4 5's, which is 20. That's root 32. And root 32 will simplify to 4 root 2, since root 32 is root 16 by root 2. So the radius of this is equal to 4 root 2.